Hey everyone, this is Derek. In this video, we're going to look at limits. And if we're taking kind of the regular calc sequence, limits would play a really big role in that. In the business calc, we're really going to use them to sort of motivate our definition for chapter 2, which is going to be derivatives. And with derivatives, what we end up doing is we sort of sneak around dividing by 0. And limits is this little kind of piece of math that's going to let us do that, essentially. And so this first video, or there's going to be 3 videos on this. In this first one, I'm just going to try to get through the notation and hopefully try to make that make a little bit of sense, because the notation is a bit intimidating. And then we'll look at the idea of a limit, both kind of in terms of a picture and a table, and kind of see how that looks with the definition. Okay, so the way this reads is the limit of f of x as x approaches c is L. So the limit of f of x as x approaches c is or equals L. And what this is saying, I think the easiest way to try to describe that is with a picture. So I kind of made a little sketch here. Let's say x is this is some value c right here on our x axis. And as my x values get closer and closer to that value c, then I'm getting closer and closer. My y values are getting closer and closer to this value L, whatever that is. And likewise, if I came in from the right-hand side and got closer and closer to this value C, right, then my y values are going to get closer and closer to that value L. That said, this value L, it has to approach a value that exists, which is to say it doesn't go to infinity, but the point may or may not be there. And that's kind of where this limit thing comes in, is we're not saying what is the value of the function at C. You know, if I color in this point and say what's the value of the function at C, then the value would be L. But with how I have this drawn with this hole here, what's the value of the function at C? It's nothing, it's not there, it's a hole. But we can talk about, okay, so at C there's nothing, but what if I was like really super close to C? What would that be looking like? And then we'd say, yeah, it kind of appears it's going to L. So the point may or may not be there, but again, the idea of a limit is that we can come at it from either direction and we're approaching a value, whether that value exists or not. So the second part of this is the limit exists if and only if both the left and right hand sides are equal. So that's what I was just saying, is that we have to come in towards the same point, while again the point may or may not be there. We can't be heading towards different points. And then this is just the sentence in math right here. Oh, let me show you this, a little bit of notation. This is probably hard to see. So this says x goes to c with a little negative there. It means from the left, and then x goes to c from the right. So that's what the little plus and minus are. So from the left-hand side and from the right-hand side. Okay, so there's sort of the notation and the general idea. So now let me show you what this will look like with a couple of examples that are more like what you'd encounter on the homework. So for the table version, if we look at this first table, and these are representing the same function, it's just from the left-hand side and from the right-hand side. So whatever's going on here, it looks like we got, 3, 3.5, 3.9. We're getting, it appears as though x is going to approach 4, is what's happening on this side. And likewise, if I look at this table from the right, we're starting at 5, and we are getting closer and closer to 4. And so if I'm going to write that in kind of proper notation, this would be the limit as x approaches 4 of f of x. That's our function. What value does it seem like it's getting closer to? So 7, 7.6, 7.9, right? This kind of feels like it's heading towards 8. So looking at this, as the x is going to 4, the y value is going to 8. So down here again with proper notation, we'd say the limit of the function as x approaches 4 appears, at least from this table, to be 8. If I come and do the same thing on this side, because again, this is describing the same function. So here it appears as though the y is getting closer to 10. And so this is where the limit's not going to exist, because on this side, as x approaches 4 from the left, it's going to 8. As x approaches 4 from the right, it's going to 10. So there'd be this gap. And again, in proper notation, just to show it. So this would be, oh shoot, I forgot my minus here. This is from the left, and this is from the right. But so we can see the left-hand limit and the right-hand limit, they don't equal each other. They're not the same. This side we're coming in towards 8. If this was some graph, this side would be heading towards 8. And then I'm not sure in terms of this side would be heading towards 10. And so there would be this gap. And so that's what it looks like where the limit wouldn't exist because the right and left-hand sides aren't equal one another. Okay, so this next example is just to kind of show a bunch of different versions of when the limit would and would not exist. So for A, it's asking us find the limit of f of x, and that's this graph over here, as x approaches 1. So as x approaches 1 from the left, it looks like it's going to 2. As x approaches 1 from the right, it looks like it's going to 2. So pretty much our limit, and then does the limit exist? Is the 2 exists? Yes. And it's not that the point's colored in; it's that it's not infinite. It's that there's a value that they're both approaching, and it's the same on each side. And so in this case, our limit would be 2. For B, it's asking us to find the limit as x approaches 2. So it looks like from the left and right hand sides, I'm approaching 3. Again, the 3 doesn't have to be there. It's just that it's approaching a value 3, whether or not that 3 is a part of the domain or not. So in this case, our limit would be 3. For C, same idea. So here we're approaching from each side, and we're approaching 1. But then here at D, this kind of messes up. So if I approach 4 from the left, then it appears as though my function is going to 2, right? So my y value is going to 2 in that case. But when I approach x from the right, 4 from the right, then my y values are going to 3. So in this case, and then the function is defined. I mean, these points exist, but they're all different. We're not going to the same point. So that's the case where this would be a D and E does not exist. Okay, so this one is another one based on a graph, but this time we're going to look at some that go to infinity, and I'll do another video of these with the algebraic version of this and then refer back to this picture. But this time for just the picture version, this is asking us, what does the function approach some value as the x values go to the infinity? So as the x's go out forever, do the y values tend towards a value, or do they also explode to infinity? And so if we look at this graph, and I probably could have made this graph a little more definitive as I'm looking at it now, but it's the idea that it's going to do this. It's going to asymptotically approach this line, kind of both directions there. And so as the x values go to infinity, it appears as though the y's are going to get closer and closer to 2. And so that's what's meant by a limit involving infinity. Likewise, this is asking the same thing, but to negative infinity, and we are still approaching 2. So the y values will get closer to 2 as the x's go to negative infinity. And then here for part C, we're asked to find the limit of the function as x approaches negative 3. So if you look here, as I approach negative 3 from the left, my function is going to positive infinity. So right there, my function, that isn't a value, so that's what's meant by the part in the limit definition. Let me grab that back. So it's if and only if the limits from the right and left hand sides both exist and are equal. And so here they're going to both be, they're going to positive infinity and negative infinity, and neither of those exist. So this is very much an example of a does not exist.